In section 4.6, we're going to learn how to complete the square to solve a quadratic equation. So basically what this means, completing a perfect square trinomial allows you to factor the completed trinomial as the square of a binomial, which I know kind of sounds like a mouthful right now, but we'll get into what that means in the next couple examples. So before we get started, we're going to be working with solving with square roots, so let's go over a couple of how I would work with that. So first, I want to solve the equation 4x squared plus 10 equals 46. Similar to all the other equations that we've done, first I'd want to get that x by itself. So I'd have to subtract 10, divide by 4, and now I'm left with x squared equals 9. My last and final step is to take the square root, and my final answer is x could equal positive or negative 3. So you might be wondering, why would I have positive or negative 3? If I work backwards, 3 squared equals 9, so that's good to go. But also, negative 3 squared also equals 9. So whenever you take the square root of a value in an algebraic equation, know that you could have a negative or positive root there. And because I have those kind of two different values, that's also kind of why a quadratic has that parabola-shaped graph. So my final answer again here, x could equal positive or negative 3. Both of those work as a solution. In part B, I have 3x squared minus 5 equals 25. Again, I'll just want to get that x by itself. I add 5 on both sides. I divide by 3. Now I'm left with x squared equals 10. When I take the square root here, 10 is not a perfect square. I'm going to leave it as a radical. So my final answer for this equation would be x equals positive or negative square root of 10. So now I want to work with a perfect square trinomial equation. I want to solve x squared plus 4x plus 4 equals 25. And what's kind of tricky about this equation to start is that I want to solve for x, I want to get x by itself, but I see that x in two different terms. And I can't combine them because one of them is x squared and one of them is just x. So I need to try to figure out a way to rewrite this equation to where I only see that x one time and I can solve for it. And thankfully here, I notice I have a perfect square trinomial, because the one number that will multiply to give me 4 but also add to give me 4 is 2. So I could rewrite this in factored form as x plus 2 times x plus 2, or more simply, x plus 2 squared. That's what I want. I kind of want to rewrite it to something like that. Now I could rewrite my whole equation as x plus 2 squared equals 25, and now I can solve for x because I only see it one time in that equation. I'm going to take the square root. X plus 2 could equal positive or negative 5. I'm going to split off this equation now, and I see that I could get x equals negative 7 or x equals 3. And those are my answers. I would recommend plugging these back in and seeing that both of these work as solutions. So sometimes you're not always just right out the gate going to have a perfect square trinomial, so that's where the completing the square method kind of comes in. So we can manipulate an equation ourselves to get ourselves into a perfect square trinomial, to factor, and then be able to solve. How we do that is we add on to standard form equation x squared plus bx, we add on, I call it a magic number, that b value over 2 squared. So what that would mean in an example, I would want to know here, what's the value that completes the square for x squared minus 10x? What I like to do when I do completing the square is I like to just draw a line for a blank space where I have to add my magic number, quote unquote. Here my b value is negative 10, so that magic number is going to be adding on negative 10 over 2 squared. Negative 10 over 2 is negative 5. Negative 5 squared is 25. And now I can see here, looking at that, now I have a perfect square trinomial, because the one number that multiplies to give me 25 and adds to give me negative 10 would be negative 5. So this could factor to x minus 5 squared. So now adding all these together to be able to solve an equation where I have to manually complete the square. I like to kind of think of a game plan or a list of steps to solve just to kind of organize my thoughts with these more challenging problems. So number one, I'm going to want to make sure that my equation looks like the form x squared plus bx equals c, so that constant term's on the other side of the equation now. Also notice that you don't see an a value here. What I'll have to do in some problems is make sure that the a value is equal to 1, and sometimes I'll have to get it that way by dividing the entire equation by that coefficient. You'll see in the next example what I mean. From there, I'll complete the square by adding that magic number. Then I'll be able to factor, And then finally, I can do the square root and solve for x ultimately. So let's look at one more example to finish this video. I want to solve the equation 3x squared minus 12x plus 6 equals 0. So in step 1, I want to get that constant term over, make sure my a value is equal to 1. So first, you can see here, I moved that 6 over, so now I have 3x squared minus 12x equals negative 6. And here my a value is not 1, so what I'm going to need to do is divide everything by 3. Now finally, I'm left with x squared minus 4x equals negative 2. So now I'm ready to go to add that magic number. So in step 2, I'm going to add a blank on both sides to know that I need to add a magic number there. My b value here is negative 4. Negative 4 divided by 2 is negative 2. So I'm going to be adding negative 2 squared. Keep in mind, I'm working with solving an equation, so if I added a number on the left to keep everything balanced, I need to do the same thing on the right. Negative 2 squared is 4. And then from here, just to simplify some stuff on the right, negative 2 plus 4 is positive 2. So now I'm left with this. And looking in that left side of the equation, what numbers multiply to give me 4, add to give me negative 4, that's negative 2 and negative 2, so I'm good to go. I can rewrite this now in factored form as x minus 2 squared equals 2. Now finally, I only see that x in one place. I'm ready to go to solve for x. So I'm going to square root both sides. I'm left with x minus 2 equals plus or minus the square root of 2. I'm going to split up that equation. Add 2, I would get x equals 2 minus the square root of 2. And then x equals 2 plus the square root of 2. And those would be my answers, and I'd finally be done.